Hello everybody, welcome to a arithmetic sequences problem at the math analysis and interpretation level. Here we have an exercise from 2015 actually, which is from math studies. And so my older videos of math studies on sequences work here as well. But I think this problem in particular is worth going over because it goes all over pretty much everything you need to know for arithmetic sequences. So first things first, an arithmetic sequence in its name, its terms are affected by either adding or subtracting. The geometric sequence, you might be able to guess now, is going to be only by multiplying and dividing, right? So that is like a general idea for now. Let's enter the problem. For number 11, they give us that the sum of the first n terms of an arithmetic sequence is given by blah. See? Anytime you see s, you need to think of the word sum, right? And so essentially, if I put s1, it's the sum of all my terms until they reach the first one. So S1 is a little bit not redundant, but more ridiculous. S1 is just going to be my first term. S2 is going to be my first two terms added together. Now you get the idea. S3 is going to be U1 plus U2 plus U3. When I put Sn, I haven't defined n yet. I haven't defined how many terms I'm actually going to get. And so that's why it looks kind of funky in this general form here, right? But that is intuition of what is S, what is S1, what is S2, what is Sn. So for part A, part I, we need to find the value of S1. Since they give us the formula in the form of Sn, all I have to do is plug in this little number here. Or let me rephrase that actually. This little number here is going to be my n, right? And so I need to do n equals 1, which is the same as just doing S1, right? And we're going to plug into this formula here. So S1 will be 6 times 1 plus 1 squared. This is, of course, 7. So S1 is going to be 7. S2, same idea, n will be 2. So I have 6 times 2 plus 2 squared. This is going to be 16. So S2 will be 16. That is part A. They then tell us that the nth term of the arithmetic sequence is given by un. Okay? And we need to show that u2 equals 9. Now let's recall, S1 was the sum of just my first term, right? S2, on the other hand, is my first two terms. So here there's like a couple ways to get u2. I think the most intuitive one for me is saying like, all right, so if I have the sum of my first term and the sum of my first two terms, I can essentially do S2 minus S1, which if I plug in what I defined up here just now is going to be U1 plus U2 minus U1. And we're going to see that I end up with only U2, which is exactly what I'm trying to find. All right, that was a lot of, letters and stuff. Let's put some numbers to it. So I'm going to plug in what I have on the bottom right over here on the bottom left. So for S2 minus S1, I would have S2, we said, was 16. S1 was 7. This will give us 9. And this 9 is equal to that U2 over here. All right, that's part B. Part C is finding the common difference of the sequence. Now, you're going to see that with arithmetic sequences and geometric. There's a lot of like fancy words we have to just kind of know, right? Well, common difference is what is D in your formula booklet. Okay, D is what affects one term so that it turns into the other one. Essentially, it's like U1 plus D will be U2. U2 plus D will be U3, so on and so forth, right? If it were a geometric sequence, it would be U1 times R equals U2. We'll get into that more in another video, but just so that we have the intuition for now, this is the difference between geometric and arithmetic sequences. So, for finding the common difference, well, it's what makes one term turn into the other one. As I just mentioned, I had U1 plus D equals U2. And as we've already seen, we have U1, we have U2, we're missing D. And so if I plug everything in over here, I'm going to have that U1 is 7 plus D equals 9. Evidently, D has to equal 2. How did I figure out that U1 was 7? Well, because the sum of my first term is 7. And so I can apply that, and bada bing, bada boom, we're good to go. Now we need to find U10. Now, I'm sure some of you guys are already thinking, all right, I can just keep adding 2 until I reach U10. And that is a valid way to do it, but you will take a little long. I suggest getting familiar with your trusty rusty formula booklet. And if you look at your trusty rusty formula booklet, you will have this equation over here on the top left that looks like that. And so how does this equation work? Well, you're trying to find this term here, your un, right? Remember that you defined un. And so if we're trying to find u10, I'm effectively saying that my n has to be 10. See? Now, in order to use this formula on the top left, I need a couple things, right? So I need an n, hopefully u1, and d, right? This is usually the kind of stuff we need. We have all of those. So let's go ahead and apply. u10 equals u1, which we said was 7, plus n, which is going to be 10, minus 1, times d, which was said was 2. So u10 equals 7 plus 9 times 2. So that is 7 plus 18. That is 25. So 25, ladies and gentlemen, is going to be u10. Again, the math isn't super complicated here, but thinking about it and getting familiar with your tools is. So always have your formula booklet open. All right, parts E and F definitely get real juicy. See? So for part E, it says find the lowest value of n for which un is greater than 1,000. So thinking about how to like set up this problem is probably the hardest part. But let's approach it with our formula booklet. Whenever you're not sure what to do, always fall back to your formulas and your formula booklet. The answer is usually there. So read carefully. The lowest value of n, okay, so we're trying to find an n, for which un is greater than 1,000. This right here, I can write it out. See? So un has to be greater than 1,000. Now, do we know what un is? You're staring at it. It's in blue. It's right up there. So here, if we plug in, actually, we have u1 plus n minus 1 times d is greater than 1,000, right? Now, never lose sight of your objective. We're trying to find the lowest value of n. So n will be our our variable, so to say. It's going to be your x. It's what we're trying to find. So we're going to plug in u1, we're going to plug in d, and we're going to find out n. u1, we said, was 7. n, we are trying to find. d, we know is 2. All of this greater than 1,000. Let's work it out a little bit. If I distribute here, I end up with 2n minus 2, because it distributes like this, multiplying, greater than 1,000. Combine like terms, 7 and minus 2, I have 2n plus 5, greater than 1,000. 2n greater than 995. Divide by 2 to get n alone. N has to be greater than 497.5. Now notice, context of the problem. Can I have half a term? In theory, like, you kind of can, but an arithmetic sequence, you're like forced to have it as u1, u2, u3. We can think of half a term, but an arithmetic sequence is only going to be like whole numbers. See? And so n, since I'm like in between both, you are forced to round it up. So my answer here actually is, given the context, 498. That is part E. Finally, the craziest part probably. So here's a challenge, part F. There's a value of n for which u1 plus u2 plus blah 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 until un is 1,512. Find the value of n. All right, so once again, the challenge here is kind of like seeing the formula in its raw form. See? And so u1 plus u2 plus blah, blah, blah until un probably rings a bell or two, or at the very least, it looks a little bit familiar. See? We saw u1 plus u2 somewhere, right? Aha, this is S2. See? And so if I keep on adding, right? Isn't this essentially just Sn? Well, it is. See? When it puts the dot 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 here, it's essentially telling you like, okay, I'm adding until pretty much infinity or until I reach un. See? That's what the dot 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 is telling you. So this whole thing here is, as I said earlier, just Sn. We have a formula for Sn that they gave us in the beginning. It's right over here. No? Look at that. And so, again, don't lose sight of what you need. Find the value of n, right? And so if all of this equals 1512, that means my Sn is 1512. So this whole thing is going to turn 1512, and this will equal 6n plus n squared. All right, now at this point, whenever you have like something squared up here, or that looks like a parabola or a quadratic formula, which is this, see? You always want to try to have it equal to 0, see? So we're going to go ahead and do that, put everything on one side. I'm going to reorganize a little bit, n squared plus 6n minus 1512, right, because I put it onto the other side, is going to equal 0, see? From this position here, there's a couple ways to solve it. I can graph it. I can do a calculator trick, calc plus intersect. I have a video in it if you want. I can also factor, and I can use the quadratic formula, see? There's a ton of ways to solve this. I will just choose to use the quadratic formula, but to each their own, see? For the quadratic formula, we have that negative b is plus or minus square root of b squared minus 4ac divided by 2a. The important part here is defining what a is, what b is, and what c is. So looking at how my box in blue is set up, right, over here, a has to be 1, because there's a 1 times n here. B has to be 6, which is this 6 right there. And c is negative 1512. Don't forget the negative. See? So I'm going to use all of this to plug in, and it will look like this. We have minus 6 plus or minus 6 squared minus 4 times 1 times negative 1512 divided by 2 times 1. So in the square root, I end up with 36 plus 6048 divided by 2 minus 6 plus or minus square root of. All right, so inside the square root, I end up with 6084 divided by 2. And now we're going to get the square root of whatever's inside, which is 78. 78 divided by 2. See? And so now we have to apply the plus or minus. On the top, we're going to have the plus version. On the bottom, we have the minus version. Up top, we have negative 6 plus 78 divided by 2 gives me 72 divided by 2 gives me 36. On the bottom, I have negative 6 minus 78 divided by 2, which gives me negative 84 divided by negative 2, which gives me, sorry, divided by positive 2, my apologies, which gives me negative 42. See? So I have a negative answer and I have a positive answer. Remember, these are supposed to be values of n. So does it make sense that I can have a negative value for n? In this case, it doesn't. You can't have negative values for n. What you can have is, let's say, a u1 that starts at negative 6. That is legal. But you can't have a negative term. See? So, in this case, I pick the positive one, given the context, 36. The answer is n equals 36. Ladies and gentlemen, that concludes this problem here. As I said earlier, I think the biggest part is getting familiar with the formulas, the formula booklet, and the fancy math language such as common difference and others. See? I hope it's helped. I'll see you around. Take it easy.